Hello, and welcome to this news event sponsored by the Nuclear Proliferation Prevention Project, NPPP, at the LBJ School of Public Affairs, University of Texas at Austin. You'll be hearing from two speakers today, and then we'll open the floor for questions during the Q&A period. The Q&A period will be for reporters only, and if you wish to ask a question, you can use the raise your hand function, and your line will be unmuted when it's your turn to ask a question. For more info, go to www.nppp.org, where you can find the news release and report related to today's news event. And we'll go ahead and introduce our speakers. As I mentioned, you'll be hearing from two speakers. First is report author Dr. Alan J Cooperman, professor, LBJ School of Public Affairs, University of Texas at Austin, where he is the coordinator of the Nuclear Proliferation Prevention Project. And second, you'll hear from Dr. Edwin Lyman, Director, Nuclear Power Safety, the Union of Concerned Scientists. And Dr. Lyman is a member of the Institute of Nuclear Materials Management, and he's testified numerous times before Congress and the Nuclear Regulatory Commission. And he co-authored the critically acclaimed book, Fukushima, The Story of a Nuclear Disaster, that was published in 2014. So let's go ahead and begin with our first speaker, Dr. Alan J Cooperman. Go ahead.
Thank you very much. So first of all, I want to thank the MacArthur Foundation, which provided the funding for this research. And I want to thank the Hastings Group for organizing this press conference. This report that we've just released reflects over 1.5 years of research. I want to make clear that before I got into this project, I had no bias for or against it. The NPPP is not against nuclear reactors. It's not against nuclear power. We do have concerns about certain nuclear fuels that are nuclear weapons usable, but that is not the case here. I picked the research topic because not only was it important, but I felt I had a rare combination of expertise to address it. I teach graduate courses at the University of Texas on both nuclear reactors and US military intervention. And I don't know if anyone else in the country has that combo. The report is, I believe, the first comprehensive analysis of these Army reactors that could affect the well-being of many US troops. So what did I find? First of all, existing enemy missiles could successfully target Army reactors on war bases. And this is illustrated by Iran's 2020 attack on Iraq's al-Assad base that injured more than 100 US troops. Such a strike on a nuclear reactor could radioactively contaminate thousands of nearby US troops on a large forward operating base. Plans to protect the reactors, that is Army plans to protect the reactors, could actually backfire by blocking airflow and thus overheating the fuel and causing a radioactive release. If US troops were forced to abandon the reactor under attack, then the adversary would come into acquisition of hundreds of pounds of highly radioactive waste that it then could disperse in hundreds of dirty bombs against American civilians. Regarding cost, I calculate that the cost of nuclear electricity using these reactors could be 7 times the current cost of diesel electricity or more. The Army's cost estimates for nuclear are artificially low by an order of magnitude. I also found, this is really important, that there is no military need for nuclear reactors on war bases. The Army has claimed that reactors would reduce casualties from delivering diesel for electricity, but I found that such casualties have been near zero for over 7 years. The Defense Science Board speculated that perhaps reactors would be necessary for high energy weapons for air defense on bases. But respectfully, that makes no sense. Nuclear reactors produce large amounts of steady state, constant electricity. High energy weapons don't need and don't use that type of electricity. They use electricity very, very rarely in pulses, which can be provided much more cheaply by diesel generators combined with batteries. My report does the math. To justify the cost of a reactor, a high energy weapon would have to be fired millions of times. In reality, such a weapon would be fired perhaps hundreds of times in its entire life. I also found that due to withdrawals from Afghanistan and Iraq, the US no longer has any war bases with over 5,000 troops. In fact, not even close to that. But you'd need 5,000 troops on a base to keep the economics of the reactor from being even worse than the estimates that I gave previously. I also found in the report that this would be a regulatory nightmare. The Army plans for these reactors to be shipped by air. But the Army doesn't want US troops to be guinea pigs on the initial deployment of a reactor. So instead, it's planning first to conduct a domestic demonstration of air deployment of a nuclear reactor before and after its operation, which raises a question. Which US states will volunteer for deadly plutonium and cesium-137 to be flown over their heads? Then, for an actual deployment, the Army would need consent from every single overflight country, in addition to the host country. Is that realistic? In light of all of these concerns, I asked the question, why is the Army spending hundreds of millions of dollars on an unnecessary reactor that could threaten the lives of thousands of US troops? Turns out the Pentagon never requested the funding. It has also never made this a program of record. The real answer is that the funding was pushed by a few lawmakers to subsidize the nuclear industry. They were assisted by a few people in the Army Logistics Directorate, that is G4, which misrepresented three key facts. First of all, the Army Logistics Directorate misrepresented the cost of nuclear energy using these reactors. They underestimated the cost by at least 10 times. Second, they overestimated the benefit of casualty reduction by over 100 times. Third, they underestimated the accuracy of adversary missiles by at least 10 times. Okay, what to do? I'll close with two comments. First of all, we should stop wasting hundreds of millions of dollars on a reactor that could not be deployed safely, securely, and efficiently in the foreseeable future, if ever. The Biden administration and Congress should immediately suspend the development program until it becomes clearer in future years whether deployment of such a reactor is both feasible and desirable. Thank you.
Thank you. Again, that was Dr. Alan Cooperman, and that takes us to our second speaker, Dr. Edwin Lyman.
Good morning, thank you. And thanks to Professor Kuperman for his excellent report, which highlights a number of serious issues associated with the Army's microreactor program. What I would like to talk about is the fact that these types of reactors are not only being considered for military deployments overseas and domestic military bases, but also they may be coming to a neighborhood near you. The nuclear industry has seized on the notion that microreactors, that is nuclear reactors with a power generation of less than 20 megawatts, potentially down to 1 megawatt, are so safe that they could be deployed essentially anywhere. The industry is pushing changes to regulations at the Nuclear Regulatory Commission that could allow these reactors to be located in densely populated urban areas without any containment building that would prevent the release of radiation in the event of a severe accident or a terrorist attack, without an emergency planning zone so that the people in the vicinity of the reactor would be prepared to evacuate or take other protective actions, such as administering potassium iodide to block uptake of radioactive iodide by their thyroid. They would not have the opportunity to develop those plans, and therefore they would be at risk if there were an accident or a terrorist attack at one of these facilities. Even worse, there are proposals that would allow reactors like this to potentially not have any armed security at all, meaning there would be no trained security officers to prevent an attack on the reactor that could contaminate the local landscape. And even worse is there are proposals to reduce the number of operators at these reactors, or even to have none at all. Autonomous reactors operating in cities with no security, with no containment, and with no emergency planning. All of that is based on a lie. The lie is that these reactors are so safe that they're essentially indestructible. Alan didn't mention that the Pentagon has also gone on record in interviews saying that the type of fuel that would be used in some of these reactor designs, which is called TRISO, is meltdown proof or even indestructible. And that really is a falsehood. This type of fuel has some safety benefits under some conditions, but it is certainly vulnerable to an incendiary attack or an explosive attack that could destroy the fuel and disperse it. Also, some of these reactors use graphite as a moderator material. That graphite will generate dust, which itself could be explosive. And there are many, many ways that a reactor like this could be sabotaged and release a significant fraction of the radiation it contains. And even a small reactor, even a microreactor, has enough radioactivity in it to seriously contaminate the landscape and be a dire threat to the public within many miles around. So there's no safety or technical basis for what is being proposed, but there's very little opposition to the changes that I've described. And with the additional financial assistance from the Department of Energy and Department of Defense to subsidize these reactors, there's a very good possibility they could be coming to a neighborhood near you. Another issue, Alan mentioned that the fuel these reactors use would not be directly nuclear weapons usable, but it is a more sensitive material than the low enriched uranium that current power reactors use, and therefore it really does require a greater level of security against theft, which would not be provided. In addition, that material could itself be used as a radiological weapon. So as we approach 20 years after 9/11, when in the aftermath of 9/11, there was great fear about the potential for terrorists like Al-Qaeda to use dirty bombs using radiological materials that are located at places like hospitals that are not well secured. And today we're talking about actually building additional facilities all around the country that would essentially be unprotected dirty bombs. And this is absolutely out of step with what the US needs, both with regard to climate mitigation and security and economic viability. So there's really no valid purpose for these microreactors, and they are all risk and no benefit. I'll stop there and I'd be happy to take your questions. Thank you.
Thank you. Again, that was Dr. Edwin Lyman. And that takes us to the Q&A portion of the call. If you wish to ask a question, use the raise your hand function, and your line will be unmuted when it's your turn to ask a question. And as a reminder, the Q&A period is only for reporters. If you're having any issues with your own audio or the raise your hand function, you can use the text-based Q&A box, and we'll do our best to get to all the questions. And before we begin, reminder that there will be a video recording of this news event available online later today. It'll be at www.nppp.org, along with the report and related news release. So again, that's www.nppp.org, no spaces. So let's check on our questions. Looks like we don't have any questions quite yet. As a reminder, you can raise your hand if you do have a question, or use the Q&A box. Oh, Here we go. We've got a question coming in from Wayne Barber of the Exchange Monitor. And Wayne, go ahead and unmute your line. Okay. I'm going to ask you to unmute, Wayne. So. Okay, well, Wayne, I think you typed your question into the Q&A box, so we'll just take it from there. The question reads, how are these microreactors different from the reactors the Navy uses in nuclear submarines?
Okay, I'll take a first shot at that if that's okay. So there's a number of differences. Naval propulsion reactors are higher power. Naval propulsion reactors are pressurized water reactors, which are similar to, although a little bit smaller than traditional ground-based nuclear power plants. But Wayne, the key difference is that we assume, and I think rightly so, and empirically so, that our adversaries cannot target our submarines, nuclear propelled submarines, whether they be SSN attack submarines or SSBN ballistic missile submarines. Those have not been targeted successfully by the adversary. Therefore, the reactor is not going to be targeted successfully by the reactor. So that's a major difference with what we're talking about in terms of putting Army reactors on forward bases. We know that these forward bases can be targeted by adversaries. In January 2020, Iran successfully landed 11 missiles on an Iraqi base with US troops. And if we hadn't gotten early warning, there would be a lot of dead Americans. Even with the early warning, there are over 100 American troops with brain injuries and over 20 Purple Hearts as a result of that attack. So that's a major difference. And then the second major difference is need. One can argue that there is a need for nuclear reactors for propelling naval vessels. With nuclear reactors, you can stay submerged and on station for a much longer period of time than you could with a diesel electric propelled submarine. So there is a need, at least arguably, for nuclear reactors for the Navy. There is no need for the Army to have nuclear reactors on forward bases. There is no need. They don't reduce casualties. They don't reduce costs. They increase costs. They increase threats to the lives of US servicemen and women. They are not needed for high energy weapons. They are not needed. There is no need. So what you have are all cost and risk and no benefit. Thanks. Ed, you want to pipe in?
No, I think you covered it well. Thank you.
Okay, great. And our next question comes from Stephanie Cook at Nuclear Intelligence Weekly. Stephanie, you can unmute your line.
Yep. Hi, Ed. Hi, Alan. I have a quick question. I recently interviewed the CEO of X Energy, and the way he explained the microreactor was that it would mainly be used as a source of power at the base, rather than, for transportation and other stuff. But I didn't get the impression he was talking about actually using it. I don't quite understand how it gets used for weapons. Maybe you could explain that a little bit more.
Sure.
I had the assumption that he's talking about, just powering, computers or whatever. And, but I may have been mistaken on that. And I immediately wondered, well, why couldn't you just use solar power batteries for that? It's a little safer, but anyway.
Okay, thanks very much for the great question. If you look at the 2016 Defense Science Board report, that was the result of a congressional mandate. This whole program is the result of a congressional mandate. As I mentioned, there's a couple people in the Army G4 that are pushing it, but the Pentagon has never embraced it. It's been Congress that has insisted. And I go in the report, I go through how for a decade they've pushed this to the point where they finally got the funding approved, and then that compelled the Pentagon to put out a request for solutions, and now they are funding the development of these prototypes for a test in 2023. But as part of this process, Congress required a report, and the Defense Science Board issued that report in 2016, and they're the folks that lay out all the potential needs for greater amounts of electricity on forward operating bases, which I call war bases. They're US military bases in war zones. And they're the ones who highlight the potential use of nuclear reactors for electricity to power high energy weapons. They talk about other things. They talk about electric vehicles. They talk about greater demands for electricity for data processing, for additive manufacturing and things like that. But the one that's really, I think, caught people's attention and seems to make sense on first view is high energy weapons. Well, doesn't a high energy weapon need a large power supply that produces a lot of electricity all the time? And the answer is no, not at all. And so I didn't know this beforehand. I spent the last year and a half learning about high energy weapons, amongst other things. But to get a shot off from a high energy laser for air defense to shoot down an incoming missile or cruise missile or drone, something like that, each shot costs approximately, according to the military, $1 to $10 of diesel fuel. $1 to $10 of diesel fuel per shot from such a high energy weapon. A nuclear reactor, microreactor, will cost on the order of 100 million to 200 million. And so that's why I say that you would have to fire this high energy laser millions of times to justify the cost of a nuclear reactor. But we're not going to fire it millions of times. We may never fire it. We may fire it at times when Iran attacks with missiles. Iran fired 16 missiles, so we might fire it 16 times. We might also train. We might fire it another 20 times. So I don't know, hundreds of times in its life it'll be fired, but not millions of times. And it would have to be fired millions of times in order to justify the cost of a nuclear reactor. The other thing, as I mentioned, is that the way these weapons work is that most of the time they consume zero electricity. It's only when they're getting ready to fire that they require electricity to flow, be stored in some kind of storage like a battery. And then when they fire, boom, they release that electricity. It fires the weapon. It also produces lots and lots of waste heat. And that waste heat then needs to be dispersed over time, because otherwise it'll melt the weapon. And that means you can't actually fire the weapon that much before you have to let it cool off, dissipate the heat. And while you're dissipating the heat, you take a little sip more of electricity into your storage for the next shot. So, for those few minutes per year when the weapon is firing, you need an electricity supply. And that can be provided perfectly by a diesel generator. But this type of weapon that's going to operate for a few minutes a year is the worst possible justification for a nuclear reactor, which is going to operate 24/7. And that's also why the cost makes absolutely no sense. I hope that explains it. If it doesn't, please let me know.
Thank you. Real quick, we're going to take a question in the Q&A box from Todd South at Military Times, and then we'll take a follow-up from Stephanie Cook. So from Todd at Military Times, can you summarize some of the Army or Department of Defense past Cold War era efforts you mentioned in your report regarding mobile reactors?
Okay, I'll start on that, and then I think maybe Ed might want to contribute as well. A few things. First of all, these programs ended in the 70s because they were simply too expensive, and there also were some accidents. And those are exactly the same concerns that we have 50 years later. Second thing I'll say is these reactors were not deployed to war zones. They were deployed to bases in peaceful areas. So this whole idea of threats to reactors from enemy attack didn't exist, because the enemy wasn't going to attack these reactors unless we had a general war with the Soviet Union or something like that. And then, the third thing, of course, is that our enemies didn't have the kind of precise precision-guided munitions then that they have today. So I think that these reactors were generally regarded as an unsuccessful program. And there have been, since then, since the 70s, there have been a few looks back to say, well, maybe we should try this again. And every time it hasn't occurred, because people realize what the downsides are in terms of risks to troops and exorbitant expense and lack of need. So I'll leave it there, but I'll turn to Ed, because I know he knows the details of these reactors a lot better than I do.
No, I think that's right. There were, about 10 small and mobile reactors that were built under the Army nuclear power program, and they were generally unreliable, and the Army terminated the program because for the good reason that it was not successful. I think I would mention is that the legacy of that program is still something the Army has to deal with today. So I believe there's a small reactor at Fort Belvoir in Virginia near DC that is only now being decommissioned, many decades after it shut down, and that's been the case for other legacy sites like Fort Greely in Alaska as well. So these reactors actually turn into a long-term radioactive waste problem for the Army, which is the last thing that it really needs or wants. And I would agree with Alan about the lack of interest within the Pentagon itself. This program does seem to be generated by the suppliers and the vendors who are looking for a government handout. Essentially, the nuclear industry, I think, is jealous of defense contractors for the way they were able to secure long-term, bloated Pentagon contracts, and I think they were very happy to be able to plug into that model. And I did hear directly at nuclear industry conferences about their attempts to lobby the Pentagon for this program, and how they were unsuccessful until recently. So it does not seem to be driven by actual military needs, but just a concerted industry lobbying effort, and that's very counterproductive in my view.
Great. Well, thank you. And we're going to take a follow-up now from Stephanie Cook, Nuclear Intelligence Weekly.
Hi. Yeah, I just, thanks for that explanation. The answer, let's say the picture that the CEO of X Energy paints is that the use of diesel is like 20th century dated technology, and that he kind of draws this picture of lots of trucks shipping big gallons of fuel around, and how awkward it is for the Army, and that these reactors you can kind of like pack in your suitcase practically and start up really easily, it's just more kind of like efficient. But my question is, if diesel is uncomfortable for the Army to use, or it really does create logistical problems to ship it around, why can't they look at other solutions? What other solutions might there be? Let me put it that way, to supply this power.
Sure. Okay. Well, thank you. Few things. First of all, there was a problem with diesel deliveries over a decade ago. But that problem has been fixed. And so let me just show you this visual from the report. Alrighty, and then I'll enlarge it for you. Hopefully this will work. Okay, so there you go. So yes, in the 5 years from, or in the few years, 2005, 2006, 2007, there was a problem with delivery of diesel. There were casualties associated with it. Now, most of that diesel wasn't actually for electricity generation, it was for vehicles. So most of these casualties weren't the result of delivering diesel for electricity generation. But in any case, there were substantial casualties. But if you notice, by around 2010, and then especially 2013-14, they went virtually to zero. In other words, the US military has figured out how to deliver diesel fuel without getting Americans killed. And so if you look at the Army's G4's 2018 report advocating these reactors, their main argument is because it's going to save lives from casualties from delivering diesel fuel for electricity. And that's just wrong. So I don't know if that was ignorance on the part of the Army or deliberate misrepresentation on the part of the Army. But you know what? I don't have access to classified info, and I figured it out. I and a master's student at the LBJ school, I figured it out. So how come the Army G4 couldn't figure it out? I find it extremely disturbing that we are funding a program that's going to cost hundreds of millions of dollars just for the first prototype, and it's based on a lie. I use that word deliberately. So that's first of all. Second of all, are there alternative energy sources? And we looked at that in my project over the last year and a half. And it turns out that certain coming out of Turkey that looks at wind power, but really I doubt you're going to want to use wind power or solar power at scale at a forward operating base. So for rear bases, you could do that, but not at forward operating bases. So then the question is, well, what else can you do? And as I say in the report, the existing diesel combined with batteries is a good thing. When you combine it with batteries, you need a lot less energy production capacity, because when you are producing at times of low demand, you store that up, and then you can use it at times of high demand. So your capacity requirements go down a lot. The other thing the military is doing is conservation. They are, for example, the greatest use of electricity on forward bases is for air conditioning in barracks. And so what they've done is a couple things. First of all, they've started to insulate barracks, and you get huge energy savings from that. The other thing is that they haven't had thermostats in these barracks. So instead, all they have is an on-off switch. So it's really hot when the troops go to sleep. So they turn on the air conditioning. And then it stays on all night at full blast because they only have an on-off switch. And by the morning, the troops are freezing. They're huddled under blankets. It's extraordinarily wasteful of energy. So they made a simple decision. We're going to put thermostats in our barracks the same way that your home has, my home has, hotels have, offices have. And with these sorts of savings, they have figured out that they can cut diesel requirements by more than 50%. So really, that's the answer. The way they have to supply energy more cheaply and safely is to use less energy through smart things like conservation and energy storage. Thanks.
Great, thank you. See, we don't have any more questions queued up at this time. Reminder, if you want to get one last question, and you can use the raise your hand function or take advantage of that Q&A text box. But we do, as we're closing, want to make sure you know where to get more information following today's news event. So if you need to connect with either of the speakers you've heard from today, or just to get more info, you can contact Max Carlin, 703-276-3255. Again, 703-276-3255. And a recording of this news event will be up online later today at www.nppp.org. It's also where you can find the report and the related news release. And I'm just going to do one last check for questions. I'm not seeing any questions, so I'm going to go ahead and thank everyone for joining this news event sponsored by the Nuclear Proliferation Prevention Project at the LBJ School of Public Affairs, University of Texas at Austin. And that concludes today's news event. Have a